in our Webinar Wednesday series. We are thrilled with the tremendous turnout for today's presentation with over 230 attendees registered. TechNation is proud to offer these free webinars as a way to educate and provide valuable information to the healthcare technology industry. We will offer 1 to 2 webinars a month on Wednesdays, focusing on issues pertinent to the biomed, clinical engineering, and imaging service community. We will always schedule the most sought-after and dynamic speakers in the profession. We would like to mention that many of these same speakers and presentations are held at our biannual MD Expo. Our next MD Expo will be held March 29th to 31st in Nashville, Tennessee. Please visit mdexposhow.com for more information. Our next presentation will be on October 29th, featuring Frank Magnarelli. Frank will present how to enlist the support of administrators to reduce your hospital's dependence on maintenance agreements. You won't want to miss that one. A few notes before we begin. Your participation today makes you eligible for 1.5 CE credits. A survey about today's presentation will appear on your computer screen immediately following today's webinar. Once the survey is complete, we will email you your certificate with the CE credits within 1 week. If you do not receive the survey, please email us at webinar@mdpublishing.com. Earlier today, registrants were emailed a Wednesday webinar workbook. If you did not receive a copy, you can download one by visiting imtechnation.com/webinars and clicking on today's presentation. During today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions feature on the dashboard on the right-hand side of the screen. Again, if you have any difficulty, please email us at webinar@mdpublishing.com. Okay, TechNation would like to thank our sponsor today, Advanced Ultrasound Electronics. AUE is a leader in refurbishing ultrasound parts, systems, peripherals, and service by using cutting-edge technology to repair parts down to component level. It is AUE's goal to provide high-quality workmanship and customer service on every part and system they offer. Visit www.auetulsa.com to learn more. Our presenter today is Jim Carr, who has over 30 years experience in diagnostic imaging in the disciplines of field service, quality assurance, regulatory affairs, manufacturing, product development, and technical support with companies including Technicare, Johnson & Johnson Ultrasound, and Accuson. He is technically trained and experienced in servicing multiple imaging modalities, including MRI, CT, endoscopy, mammography, and ultrasound. Most recently, he provided leadership for the technical operations and quality systems at multi-vendor service organizations as the Executive Director of Service Programs for Unison Medical Technology and as VP of Operations and Quality at Sonora Medical Systems. Jim, the stage is yours.
All right, John, thank you very much, and thank you to MD Publishing for putting on these webinars and giving us the opportunity to present the information on the ACR accreditation for ultrasound today. So in April of 2014, earlier this year, the American College of Radiology revised their accreditation programs for ultrasound and breast ultrasound. So we're going to talk about today the requirements for submitting for accreditation and the responsibilities for that. And then I'm going to talk about the performance testing that's needed to meet and exceed the requirements for ACR. So what procedures and processes can you use, what tools are available, how effective are they? And then I'm going to talk about preventive maintenance and testing techniques. So the reasons that facilities go for ACR accreditation are typically for reimbursement purposes. So this is a way for them to be audited and meet the requirements of CMS without having to go through Joint Commission or other methods. Also for marketing purposes, just to be able to have that ACR accreditation plaque out in their office is one reason that many places do it. And then another good reason is to try to ensure some sort of level of quality care and improve that level of quality of care. So there's 6 programs involved in the diagnostic modality accreditation program for MRI and CT and breast biopsy. And the ones that we're going to talk about today are for breast ultrasound and for ultrasound. So there's a 2-step process for application. You have to submit some information about the practice, the site where that is applying for the accreditation. And that has to do with the personnel, the training and experience, and also the equipment that is used by the facility. And then a submission of clinical images needs to be made, and also modality-specific quality control and quality assurance program information. The breast ultrasound program is very similar. It does have a little bit higher requirements for the clinical training and experience at the site, and it actually says in the accreditation program for breast ultrasound, the ACR says that it provides facilities with constructive feedback and review, peer review of the qualifications, quality control, quality assurance, and the accuracy of the clinical studies that we're doing. The QA questionnaire for the breast ultrasound program is slightly different than the ultrasound one, and I'm going to go over that. I'm going to go over what the differences are and what's required. Most ACR accredited facilities that are in breast imaging clinics are also regulated by the MQSA, the Mammography Quality Systems Act, FDA law that was passed that regulates mammography systems. So part of that is that they're required to have a physicist either on staff or as a consultant. But quite often in my experience, that physicist may not be qualified for ultrasound. So unless they've studied some of the ultrasound physics and the unique part of that, they may not actually be qualified to do this job. So fortunately, the ACR has accommodated for that. That's one of the main changes they made for 2014. So the ultrasound accreditation program as it stands today, there is QC documentation that's required as part of the application. There should be a report from the most recent annual survey, and I'm going to talk about that later, that has been performed by the medical physicist or their designee. If there was corrective action taken as a result of the annual survey, then documentation actually needs to be submitted that shows that the problem was fixed. The requirement for the medical physicist has changed now. So it used to be you had to have a physicist sign off on everything. Now the lead physician at the practice may designate someone who they believe is qualified to perform the duties that previously only a medical physicist was allowed to do. Preventative maintenance as part of the ultrasound accreditation program must be scheduled, performed, and documented by a qualified service engineer. I'm going to explain what that means to ACR. The time frame they say you should do it on is on a regular basis. So the time frame can be established sometimes by looking at the manufacturer's manuals, or you may want to make a determination yourself on the preventative maintenance schedule based on the risk that that system is under. So the higher the risk, obviously, the more often you would want to check that system to make sure things are correct. An annual survey of the program is required. So that's a combination of results of the complete QC test activities for the past year and also an evaluation of the QC program. And that needs to be made by somebody who's not actually running that program. So it's supposed to be some outside person or a third party that is qualified that takes a look at the QC program and writes an evaluation of it. There is quality control now required as part of the ACR ultrasound programs. So I'm going to go through the different types of quality control and whether it's required, optional, and what the ACR says about that. Acceptance testing used to be required. It is now optional, and the ACR says it should be performed, which I would agree with, by the way. And that should include, or it does include, transducers. It should be done after a repair to make sure that the equipment is working properly after the repair. And the acceptance testing, if it's done, should include all tests done for the annual survey. QC tests are now required to be done annually. You can have up to a 14-month gap, and it needs to be submitted as part of that annual survey. And then a continuous QC program is now optional. But what the ACR says about it, I would definitely back that up, which is a continuous QC program is essential to assure that everything's working correctly, and also to identify problems before the system isn't able to be used for diagnosis. In other words, let's make the uptime as good as possible, and let's make sure it's working properly. And frankly, it's a little hard to disagree with that, but it is optional to do that now. And one of the things that they changed is the verbiage about who does that. It now says that it's typically performed by trained sonographers or equipment service engineers. And I do know of some sonographers that actually either have some test device and they have learned how to do some of the QC tests, and they're actually doing the QC on their system. And frankly, as I'm going to talk about a little bit more, the users need to be part of an ongoing quality control program for several reasons. So there's a quality assurance question that needs to be turned in when you submit for accreditation. It is not revised yet. So the ACR, when they make these large changes to their programs, in the past this has happened where it takes them a few months to get everything in sync. So this is one that's hasn't been revised yet. It's been since 2010 that it was revised. So there's some clinically related questions, which the ACR says is mainly for survey purposes. And they also ask about policies and procedures, like the disinfection procedures, for instance. And they want information on the clinical personnel, their background and education experience. And for us, the important thing for us TechNation folks is that a quality control plan is to be submitted. There are 8 activities listed on that plan. The ACR gives us a form to use. You need to identify the frequency that is going to be done, that test or that activity, and also who is responsible for performing it. So let's get into that testing. This is the nuts and bolts for us tech folks, the QA and performance testing needed for ACR accreditation. The requirements for the quality control personnel. The ACR still strongly recommends that it be done under the supervision of a qualified medical physicist. But they say that they may be assisted by properly trained individuals in obtaining the data. And frankly, it's always worked that way. Even when the quality control plans were submitted by a physicist, as was required before, it's not too many places. There are some where a physicist does those tests, but usually they turn to the clinical engineers or their service engineer to do that for them, because they have the proper test equipment and know how to do that. Those individuals, though, if they're doing that, they have to be approved, should be approved by the physicist, and the medical physicist should review, interpret, and approve all the data. But again, they allow you to not use a physicist. So what they say, if it's not possible, and if you have a medical physicists on staff, but as most of them, if they're working at a clinic, they probably studied radiation safety more than other things, so they may not know ultrasound. So if you don't have that person available, a physicist that's an expert in ultrasound, then the ACR says they could be performed by other appropriately trained personnel with ultrasound imaging equipment experience. That person or persons must be approved by the lead physician at the clinical ultrasound practice. So in other words, the lead ultrasound physician at that practice needs to write a memo, basically, or a letter to file that says, we're going to assign this person to do these tasks for us, and here's the reason that they're qualified. Because the ACR actually does ask for that kind of documentation every once in a while. When they see that a physicist is not being used, they very well could ask you for some information about the persons that are doing that and what their qualifications are, and mainly have they been approved by somebody at the practice. The ACR says the training can be achieved through the OEM, the original equipment manufacturer, or through an appropriate course. And based on my years of experience working on both for manufacturers and multi-vendor service organizations, I would assert that you're more likely to get thorough training from a multi-vendor service organization. But that's not to say that manufacturer's training is not any good. I'm just saying that if you have to make a choice, you might want to look towards multi-vendor service organizations and see who's got something out there that's good. Documentation of that training is encouraged, but you're actually not supposed to send it with the submission. They actually say do not send it for whatever reason. They probably get a lot of paperwork at ACR, I'm guessing. So the quality assurance questionnaire that needs to be turned in is also still needs to be updated. It's based on the old program requirements. So it doesn't match exactly like the annual survey requirements, for instance, so they're not quite synced up yet. For each of those QA tasks, as I mentioned earlier, it has to be specified how often it's going to be done and by whom. Now these tasks, by the way, there is on most of them a checkbox that says not to be done. So you can actually opt out of some of these tests, and sometimes it would make sense to do that. But I don't know for sure because I'm not with the ACR, but I'm guessing that if you turned in your submission and you decided to opt out of every QA test, you might have a hard time getting approved for accreditation. But they do actually have a checkbox there for it. So one of those tasks is grayscale photography, and the way that we've done that over the years is basically count and compare the number of gray bar steps that are on the monitor, and then on the hard copy image, or these days we're mainly looking at the workstation possibly that they're doing the diagnosis on. So it's just how many gray bar steps can I see, and then the next time you go in 6 months later or a year later, whenever the next QA is done, can I still see that same number of grayscale shades? If you have digital printers, you need to do a hard copy output quality test to make sure that the window width and window level settings are correct. Not too many ultrasound systems use digital printers. As a matter of fact, printers are hardly on ultrasound systems at all these days because PACS networks have taken over, and fortunately, because as those of us that work on these things know, it was the peripheral devices that broke most often on these things. Electrical safety and cleanliness, so mechanically inspect the system and probes to make sure they're operating properly and clean. And of course, one would hope that as you're doing a quality assurance test every 6 months or whatever it might be, you determine is the right frequency, you would hope those probes would be clean, right? Because I'm hoping they're cleaning them off after every patient. That brings us to the next thing they ask about, universal infection control procedures. So this basically is saying make sure that the sonographers or central sterile or whoever's doing the cleanup of the system and probes after patients, or disinfecting the probes in the case of a TE probe or endovaginal, that they know what they're doing, they're using the proper materials for disinfection, they're following the procedures that the manufacturer has given them, and that they're all aware of it. Another task is to test the system sensitivity or penetration, and that's typically done with a test device like a Phantom. And then uniformity of the image, and what this means is if I have a grayscale level that indicates 50% of bright white, and I have that image on one side of the screen, does it give me the same gray shade when it's on the other side of the screen? Frankly, with the digital systems we have today, unless the monitor had some problem, it's extremely unlikely you'd ever find an image uniformity problem, but it is a test that they still require. Maximal depth of visualization and hard copy recording with a Phantom is actually listed. A Phantom actually is not required anymore. I'm going to talk about that in a second. But this is the way it's worded. Like I said, it's not quite in sync with the current program requirements. So this is basically how deep can I penetrate, right? So how sensitive is my system? How deep can I penetrate? And then low contrast object detectability. And what that means is how good is the contrast resolution of the system. So if I have, in the clinical setting, what they're looking for is if I have two tissues next to each other that have only slightly different acoustic impedance, or the tissue density, in other words, is only slightly different, we know that that creates a much smaller echo. So is the system able to detect that, and at what low levels can you do that? This actually is a difficult test to do given the current test equipment that's available. On the breast ultrasound program, the QA questionnaire, as I mentioned earlier, is a little different. It actually has been revised, but they didn't quite get it right. It still doesn't exactly match the annual survey QC test, which I believe they intended to do. Actually have asked the ACR for clarification on that as to whether they intended it to be slightly different or not. There's 12 activities recommended for the QC plan, so you might guess, or assume, I should say, that when the ultrasound program questionnaire gets updated, it's probably going to have 12 activities that look a lot like these. So maximum depth of visualization with a phantom. So again, this is one of the ones that doesn't match. It says you don't have to have a phantom. I'm not sure how you do this test, but there are ways you could do it without a phantom, but you need some test object in order to do this. So I think that's what they meant with a test object. The vertical and horizontal distance accuracy, so commonly called geometric accuracy. So this is getting the calipers on the screen, using a phantom typically, and measuring to make sure that the pins that are supposed to be 1 centimeter apart or 2 centimeters apart are really that distance. Uniformity of the image, so again, that is the contrast of a received echo. The same received echo can be displayed the same on the left and right side of the image, top and bottom, that kind of thing. The electromechanical cleanliness of the system in the probes. And then this is one that's different, that's different from the other 8 in the ultrasound program. Anechoic void perception. So what that means is, can cystic or echo-free structures be cleared out? This is a common problem for those of us that work on ultrasound. We've heard that over the years. I can't clean out the carotid. I can't clean out this vessel. It should be echo-free, should be echogenic. So that's a test of that to make sure that you're not filling it in with noise, in other words. And then ring down. So this is an interesting one. They don't really give us any instructions for this at this time. So one way to do this, the ring down is in the near field of the image. So if you look at the in-air or free air image in the near field, you will see this ring down, and as most of us know that work on these things, sometimes that ring down will show us defects, but it also can be misleading. So sometimes you can see what looks like dropouts, and you do some further tests and you confirm that there really is some problem, but you can also see what looks like defects, and then you test everything and everything's okay. So the ring down is a function of several different things: the timing of the TR switches, the way that the information is interpolated when it's received, and the quality of the transducer. If somebody put too thick of a membrane on it, you'll have too much ring down. You'll also attenuate the ultrasound more than it should be. Lateral resolution, so this is how well do I resolve targets in the lateral axis of the ultrasound beam. And quality control checklist needs to be submitted, just like on the ultrasound program. Again, this is the frequency and the person responsible for all the QC activities. Make sure you're adhering to universal infection control procedures. And this is interesting. They have a separate thing on the QA plan about cleaning transducers. This is one you cannot check, we don't do. You can't opt out of this one, by the way. There isn't that checkbox. So, and thank goodness. But daily is actually the minimum frequency that can be selected. And of course, it should be done after every patient, especially these days, right? So hopefully that is being done all the time. So this is just to say, yes, that's being done regularly because the system was clean when I checked it. And then grayscale photography. So not too many places actually are using printouts anymore. Like I said, they've gone to DICOM and PAX networks, and But if they are still using cameras and printers and those things, then we need to make sure that the grayscale output of those matches what is being seen on the screen. And then general preventive maintenance, they said preventative, which is actually an okay word, but I think preventive is better, whatever. But you do have to specify what general PMs are going to be done on the system. Again, this can be an opt-out, by the way. They do have the checkbox for we're not going to do that. And for instance, there's some systems, Sonosite is one of them, and I don't necessarily agree with this. If there's anybody from Sonosite, I beg your pardon, but they actually say no PMs are required. Well, you know, from experience of my many years, I can tell you that that just doesn't work because, unfortunately, there can be problems with the transducer, for instance, that they actually don't see yet could be affecting the ability of the system to diagnose problems. So to say you never need any PM is, to me, it doesn't really fit with the goal of trying to make sure that patients are getting scanned properly and safely. So to summarize the requirements of the performance and QC testing, an annual survey of the QC tests is required. So once a year, somebody has to look back at the QC tests that were done, what was found, and write an analysis of whether that's working or not working and what's going to be changed if it wasn't working. The QC program must be identified in the submission, but as I mentioned, it's actually optional. And the preventive maintenance must be scheduled, it's not a should, must be scheduled and performed by qualified personnel, but there's no frequency or activities, so you actually have to tell them whether you're going to opt out of this or not. So they do actually allow you to do that, but you must tell them that if that's what you've decided. Obviously, what they really expect to see is you say you're going to do your PMs every 6 months or whatever you've decided is the right time frame and who's going to do it. But they actually do give you a way to say it's not going to, we don't need to do it. If I was submitting, by the way, under those conditions, I would probably take a scan of the page of the Sonosite manual that says no PMs are required and attach that to the submission. Acceptance testing of new or repaired equipment is now optional. Qualified personnel can now be designated to perform the annual survey and the QC test. They still urge that you use a medical physicist, but the ACR works with the medical physicists around the country, and they realize that there's a small subset actually of those physicists that understand ultrasound well enough to actually design and run one of these QC programs. Test equipment is required, but it is not specified. So what it says now is you must use a test object, but it actually says a phantom is not required. It also goes on to say there are transducer evaluation devices which test the characteristics of each transducer element, and those may also be used, but it can't replace any of the required tests because the system isn't a part of the test in those cases, right? So they're talking about like a first call probe tester where it will test the transducer, it tests almost everything about that transducer. However, you do that without it being attached to the system. So while it tells you a lot about the condition of the transducer, it doesn't tell you anything about the system. So if you want to do that in addition, that's great, but you also have to do some tests where the system is included. So what tools are out there for doing this? Well, system diagnostics back actually many years ago now, we could use the system diagnostics for a lot of this, but the manufacturers started eliminating the probe testing tools about 15, 20 years ago, and now, and most of those only gave a pass-fail result anyway, like the walk test on an HDI system or the dot test on the HP systems, single line test on the Accuson systems. So those were a pass-fail. At least it did tell you whether the transmitter and the element were working. These days, though, the diagnostics that are there, if they are there, and even if you can get access to them, most of them won't even detect a dead transmitter. So obviously that's not going to quite suffice for ACR purposes or any other for that matter. So tissue mimicking phantoms, that's one of the main tools that we've used them for years. There are some drawbacks though, because when phantoms first came out, we were able to fully test systems. We could actually test things and say, yeah, this is what the axial resolution is, and this was the lateral resolution. But the systems and the probes have become so much more complex that these days phantoms are unable to detect many system and probe problems that cause erroneous Doppler readings. And an erroneous Doppler reading can lead to an unnecessary angiogram or a misdiagnosis. So it's especially important in Doppler just because of the way that the Doppler beam is affected when there's either dead transmitters or dead elements or elements not working in the probe. So for example, phantoms became widely used back when the probes had a 182 millimeter aperture, these big giant linear probes that we used to have. And some of them actually had 32 elements, but when phantoms really became popular, they had 64 elements, that means that the width of each element is 2.8 millimeters. The linear probes now being commonly used for carotid studies have 192 elements and a 38 millimeter aperture, so it'll fit into your neck. And that means they're about 0.2 millimeters per element. So you can see the problem here, if you know about test theory, that you have to have a testing device that is twice as good as or twice as accurate as what you're trying to measure. Well, it's physically impossible to put the pin targets into the phantoms close enough that we could be able to measure this. So that's the issue with phantoms. And in fact, you could do all the performance testing that would tell you the condition of the system and the probes, but you have to buy about $150,000 worth of phantoms. You have to have a Doppler phantom, an elevational beam width phantom, you have to have a high-frequency linear array axial resolution phantom, and on and on. So, and it would take you a couple of days, by the way, to do your PM if you did that. It takes about 4 hours to set up the stupid Doppler phantom. So, and the good thing about phantoms, by the way, is they've been around and people know what they are, and most of us have one. So another tool that's available that actually meets the ACR requirements is the nickel. It's a little handheld device. It was invented by Sonora Medical Systems and then became part of Unison when that merger was made. It provides very objective and repeatable tests. It is able to detect two adjacent dead elements or channels, and the reason that's important is that's when it causes the problems in the Doppler readings, in the Doppler spectrum. It meets the ACR requirements because it does performance tests using the system and probes, and that image there is a picture that shows the injected signals from the nickel. So when you use the nickel, you place it on the membrane of the transducer and you press the switch to turn it on, and it starts listening for transmitted pulses. And when it detects a transmitted pulse, it turns the LED green to tell you that the element and the transmit channel are good. When that happens, it also starts a timer that injects 3 different frequencies, a burst of energy of sound, or burst of sound energy into the nickel at 10 megahertz, 5 megahertz, and 2 megahertz, and then that gets displayed on the screen. So now you've got the nickel injecting a known value into the system, and you can now turn the gain down into where one of those bands of signals just fades into the darkness, and that's your sensitivity test. However, it's no longer available. GE was having trouble making it, so they decided to discontinue it. So if you have one, don't drop it. Make sure you can take care of it, because we're not going to be able to get another one, apparently. Fortunately, the folks that invented the nickel went and started another company, and they're working and have developed the Active-Z. The Active-Z is a little handheld device that today can test the complex impedance of every element of the array. So as you see in that picture, it's like a smartphone. It's the size of an iPhone or something. And you turn it on and you tell it, I want to test a Siemens probe. And then it asks you to select a section of the probe you want to test first. So they divide the probe up into 9 sets of elements, typically. I think it's 9. So you select one of those, and then the software inside the device says, okay, put your test lead on this pin. And so you put it there, and it tests the complex impedance from that pin all the way out to the element of the probe and back. And if it's good, it turns green, and then it turns the next pin you're supposed to probe yellow. If it fails, it turns red. And then the bottom picture there is what the test result looks like. So in this case, you see that several of the elements have the same complex impedance, and those are the elements that are good. You notice one that has elevated impedance, so that means that there's something wrong probably with the element, but it could be membrane delamination on the probe. And then you see one that has no impedance, so that would be an indication that the pin is broken. So there's absolutely no impedance, zero impedance. That means that there's no signal getting through, so you've got a broken pin or a broken wire just on the other side of that pin on the connector. The folks at ACR Labs that developed this are working on and have this working already in a prototype. They have a way to inject a known signal level into the system, into the probe connector of the system. So that means that once that's developed, by having the combination of those things, the ability to test the complex impedance of the probe, and then the ability to inject a known signal into the system and measure the sensitivity of the system, that will then give us the ability to meet the ACR requirements. So that's ACR Acoustic Labs that has the ActiveZ device. So if you're using a tissue mimicking Phantom, I have these general instructions for setting up and using a Phantom. Basically, you know, if you look at the Phantom users manuals, most of them, except for the newer manuals from ATS, will tell you that you should set the system up for the best image quality. Well, you don't want to do that because the Phantoms aren't really good enough to test these things anymore anyway. And if you follow those instructions and turn on compound imaging and all the post-processing and all that stuff, it's going to hide problems, right? It's going to cover them up. So you'll only be able to detect massive failures, like the system doesn't boot up, like almost that massive. So what I always tell people, teach people, is set the system controls for what I call a raw image. So like in the old days when we didn't have all these fancy features on the systems. So turn off Sonos CT or compound imaging or spatial compounding, whatever they call it on that system. Turn off all the post-processing smoothing algorithms that they use. Anything you can turn off. Go to one focal point. So try to make it just as raw, basic in the image as possible. And then if you're familiar with four-corner testing, where you try to test a device for reliability and you test it at the edges of the specs. So for instance, if you have a system that says the spec for temperature and voltage are this, then you would test that system at the highest voltage, highest temperature, then the highest voltage, lowest temperature, lowest voltage, lowest temperature, etc. Tested at those four corners. So what I mean by that in this case is that if we're going to test penetration, we know that it improves if you go down in frequency. So when the sonographer needs to see deeper, they always lower the frequency that they're scanning at. Well, since we're trying to make the system like push it to the edge, we want to use the highest frequency for that probe when we're testing the penetration. And with axial resolution, we know as the frequency goes up, the axial resolution improves. So since, again, we're trying to stretch this to the limits, we're going to use the lowest frequency that probe will run at and test the axial resolution. And by doing that, we're much more likely to find problems. And then, as I mentioned, turn off harmonics, spatial compounding, and go to a single focal point. And then, because you need to be able to repeat this in the future, you need to set all the time gain controls, the TGCs, to either minimum or maximum, and you'll figure out pretty quickly what it needs to be on the system you're working on. Like GE systems, it's usually all maximum. Philips systems, it's all minimum, if I remember right, and some Siemens systems, the Siemens systems kind of vary, but you'll figure it out. If you can't adjust the gain far enough to do your test, then you know you need to go to the other end. But you need to be at a known repeatable value for the TGC controls, so when you come back in 6 months, or if they call you in because something they think think something is broken, you can do that same test, repeat the exact same test with the same presets, the same settings of the system, same depth, everything, so that you're repeating the same test again. And then I've got a slide here for using the nickel, but since you can't get it anymore, I'm not really going to go through it, but basically it's the same thing. So you want to turn off all the harmonics, all those things. You want to get it down to a raw system. So performing the QC test for the annual survey. So this is the thing that has to be turned in every year to ACR. Your accreditation lasts for 3 years, and then you have to reapply. And during those 3 years, you have to do these annual surveys. So one of those things is the physical and mechanical inspection. So that's checking the trackball, the brakes, the articulation of the keyboard, control panels, monitor arm articulations, all those things. Inspecting the power cords is really important. That's a real problem spot on a lot of ultrasound systems. And of course, visually inspecting the probes, or if it's a TE probe, then doing the mechanical articulation test. And then make sure all the gels and cleaning products that they're using are on the OEM approved list, because if they're not, it's likely that that gel or disinfecting solution is going to cause damage to the equipment. And the other thing you want to make sure is, like, for instance, a lot of places now are using bleach to wipe off the systems, or using alcohol or something. They have to rinse that off. The alcohol and the bleach will attack the plastics, the rubber membranes. They can do a lot of damage in a big hurry if they're not rinsing these off properly. Then there's the image uniformity and artifact survey. So using a phantom, the way you do that is get an image on the screen with as much of the phantom as possible, and then adjust the gain upwards so that you start to see a noise level, and then look for streaks, axial or lateral streaks, or dropouts, in other words, which might indicate an artifact. And there's a trick with a phantom of moving it very fast across the top of the phantom. When you move it really fast, if there is a dropout, there's a better chance of seeing it. But frankly, it's very hard to see dropouts unless they're really bad these days, because the transducers are so dense and the systems are doing everything they can to cover up dropout. And then, of course, you want to, as I mentioned earlier, compare the grayscale levels of the background echoes on the right and left side. This is the way I do it. As I turn the gain up until there's noise, you know that noise is uniform in the system, right? Because it's just the general system noise. And then I compare the grayscale levels of the noise on the left and the right, and that's how I do image uniformity. The ACR says the use of in-error free error images may be used, but as I mentioned earlier, be cautious about that because it can be misleading. So that image I put up there, you see that dropout on the right side of the image. That actually was not a problem. When I tested it, that was one dead element, and I'm not sure why it looks so bad in the ring down, but it looks pretty bad there, right? And then that other huge dropout, that actually turned out to be membrane delamination. So that really was a problem. So you have to be careful about the in-error scans. It may or may not tell you the truth. Then geometric accuracy, this is where the calipers are measuring the distances correctly. You can use a phantom or the nickel for that. But as we know, this can't be adjusted on modern ultrasound systems. They're all digital clocks and everything. So there have been mistakes made on this, by the way, because the software engineers have to do geometric correction on mechanical and curved array and sector array probes. So if they get that calculation wrong, you can actually get the wrong caliper measurements. So what I always tell people these days is you want to measure it when you get a new system or anytime the software is updated. If they change the software version on your system, you should really check the geometric accuracy on the probes. I don't want to use a name, but a recent company came out with Rev 6 on their systems and a new probe that worked on it, and that probe actually got the geometry incorrect on it. They very quickly fixed that, and the field engineers ran out and did software upgrades to fix it. System sensitivity, so that's a measurement of the overall sensitivity to reflected echoes. I say test do this test using each transducer, but there is no requirement. The ACR used to say you had to test 2 probes at least. There's actually no requirement now for that. So this is Jim Carr saying I would test every transducer that they use. You know, they'll find transducers in drawers they never used. I wouldn't necessarily do that, but anything they're using, you should really test that. You can do that with a tissue mimicking phantom or the nickel. And if you use the phantom, the main thing here is, like I was saying earlier, since we know that sensitivity improves at lower frequencies, go to the highest frequency possible for that probe and then look for the deepest target you can see, and then turn the B mode gain down until that fades into the black level, and that's the system sensitivity test. Another test required for the annual survey is the ultrasound scanner electronic image display performance. So this, they used to say grayscale only. Now it's a little bit more than that now, with color being so widely used, and also the fact we have flat panels. So the ACR says now this may include grayscale, luminance, missing pixels, or overall image quality. So the test patterns, most of the systems, one diagnostic they do give us that's extremely useful on most of the systems is a test pattern utility. So some of them especially are actually set up to allow you to make sure that all the grayscales is being displayed. Now, of course, the systems are capable of displaying more gray shade levels than human eyes can see, at least most of them. So this is what we can see, right, what a human is able to see. So those test patterns come in really handy. Also, they have a lot of them now that'll turn all the red pixels on, all the green pixels on, so you can use that to look for the missing pixels. The manufacturers typically don't give us any specs for this, and they don't give us specs for too many things except electrical leakage usually. So some of the suggested measurements for this is the number of gray steps that you can see, or your ability to visualize a full range of gray in all the colors with no more than so many missing pixels. There are some standards out there for this that you can try to use to adopt one. ACR suggests using this standard, the ACR AAPM SIIM technical standard. They suggest using that for additional information on tests and testing methods. Then you're also supposed to make sure that the display they're using to read the scans is working properly. So since so often these days that is not the ultrasound system itself, that's why they have this in here. So that would be the workstation, or if they're actually using printouts, the printouts. Contrast resolution is optional. Those other tests are required, by the way, for the annual survey. Contrast resolution is optional. You can test this kind of with a phantom with the grayscale targets in the phantom, but the thing is that a ultrasound system these days typically has about 90 dB of dynamic range. That has to get compressed down to about 60 dB because that's about all the human eye can see in dynamic range. And the targets that they put in these phantoms are typically at the most maybe plus and minus, or maybe 24 dB it'll cover, plus and minus 12 dB. So obviously that's, you know, like nowhere near what the system is actually capable of. So basically, if you can't see all those grayscale targets, you've got something really messed up. The nickel actually doesn't test this directly, but you can perform sensitivity tests at different frequencies and gain settings, and so then you can come to the conclusion that it's able to amplify properly at different frequencies. And of course, bandwidth is a big part of contrast resolution, so that's a way to test for this with the nickel. So there's some ultrasound resolution tests that need to be made, and they would like us to measure it in the axial, lateral, and elevational directions, as illustrated there in my little diagram. Phantoms are really unable to measure axial resolution on most systems and probes because the target pins just can't be placed close enough, so you can almost always see all the pins. That basically means you can't test it, right? If you can't make it break, you can't measure it. So that's the problem with phantoms today. So again, if you go to the absolute lowest frequency for that probe, at least you have a chance of seeing something if it is going wrong. And then the elevational beam width phantoms are kind of expensive. There is a way to use a general QA phantom and do an estimation of the elevational beam width. There's the white paper that a medical physicist wrote on this that's available that you can use to try to do that. And elevational beam width is not always controlled that well by the manufacturers. They have to make trade-offs in the resolution, and elevational beam width is one of the ones they sometimes trade off. The elevational beam width will start deteriorating pretty quickly when you have dead elements or elements that aren't working or channels that aren't working. The nickel and the active Z can't test resolution directly, but they can test to make sure that the transducer and the system are working correctly. So we can make sure everything's working the way it was supposed to, so then we can assume that it's working properly because everything's working the way it was designed. So it's producing the resolution that the system is capable of. And as a service provider, that's really all we're able to do, right? We don't have real specs for this that we can follow. So if you're doing axial resolution with a phantom, you want to try to go again to the lowest frequency possible. Lateral resolution, this you can measure with phantoms. So lateral resolution is perpendicular to the main lobe, and this is the most likely measurement to show changes in measurements due to defects in the transducer of the system. So the width of those targets will start increasing when you start getting problems. And then the QC program needs to be evaluated. So annually this evaluation needs to be done, and that's the form that they give us to use for it. So that's only applicable if the optional QC program has been established, right? And it is supposed to be an independent assessment of your QC program. And that gets recorded using this Excel template that you can download from the ACR website. So a continuous QC program is optional. I strongly urge you to adopt one if you don't have one already. It's typically performed by appropriately trained sonographers or service engineers. Corrective action must be taken if any of the tests fall outside the limits, of course. And the test should include physical and mechanical inspection, image uniformity and artifact survey. Geometric accuracy for mechanically scanned transducers only is what they say. However, as I mentioned earlier, if you've had a software upgrade lately, I would check it at least once to make sure all the probes are still measuring correctly. The ultrasound scanner electronic image display needs to be checked, and then if that's not used for the diagnoses, for making diagnoses, the workstation display needs to be checked. Preventative maintenance must be scheduled, performed, and documented on a regular basis. And service must be done to correct any deficiencies found, and those need to be documented and those records maintained. So the ACR may ask you to see those records at some point as part of their auditing. And my suggestion is this could be part of the annual survey. The annual survey and the PM should overlap, right? You should be doing basically some of the same tests or these same tests. So the schedule and activities or the proof of PM performance don't need to be submitted, but as I said, they may ask you for them. The OEM documentation may have a schedule and activities performed, but usually not, unfortunately. And actually the GE user and service manuals contradict each other on what the schedule should be. One says you don't need any, the other one says one per year. So what I say is that if you perform PMs properly using the principles of evidence-based quality assurance, you will assure that the system is performing properly to provide a diagnosis, and you'll also make sure that it's safe to use, so you're not going to hurt somebody with it. And actually it's been proven you will reduce your overall operating costs, because if you do these on a regular basis, you'll find problems when they can be fixed for a little less money than it might cost. So for instance, a good example is a transducer with the membrane is starting to delaminate. You see a little bit of dropout. If you don't catch that in time, the membrane separates far enough, and then stuff starts getting underneath the membrane into the array, and eventually it will destroy the array. So you've gone from one of the most inexpensive repairs of a probe to having to replace the probe. So some of the key items: mechanical checks and maintenance, so lubing, cleaning, adjusting, cleaning the air filters. Of course, the users need to be doing this on a regular basis. Most of these systems really need to have the air filters cleaned quite regularly, especially in some facilities where it's dusty. Backing up the data. So, and this is what I say should be done in PMs. The ACR actually doesn't specify anything. So some of the things should be done: backup user presets, the calc programs, and I always leave one with the system and one to keep in the biomed shop or one to take back with me. And then hard drive maintenance. So some of the systems have utilities for resetting the database that completely clears it out. It's a really good idea to do that on a regular basis. Some of the user manuals actually say they should do it every 2 or 3 days, or even daily. GE says do it daily. So that's an important step to keep the hard drive from getting corrupted. And then on some systems, making an image copy of the hard drive is an important item. But regular maintenance by the users is absolutely critical. They're there with it every day. We can't PM the thing every day. Even every 3 months might not make sense. But if the users aren't involved with doing these, with doing these regular checks, then that system is at higher risk of having something happen to it. So I would increase the PM frequency, for instance, in that case, because I know it's under higher risk of having something happen to it. All right, so to wrap up, I want to give you an idea of the resources that are out there. So the you can get training and technical support, of course, from AUE, Advanced Ultrasound Electronics. We have a training program schedule and a description of what we train about on our website. The ACR has some documents you can download that describe the programs, the spreadsheet to use for the annual survey, and there's this technical standard for diagnostic medical physics performance monitoring of ultrasound equipment, which actually was published as a guide for how to do these tests. It needs to be revised also, so it's a little outdated for the current requirements, but it is a good reference document. The manufacturer's users and service manuals may have PM manual. They may also have a PM manual separate, by the way. Some companies do that. And it may have a procedure that you can follow, and very often they'll have one that tells you how to test all the buttons, and that's one of the things that we should be doing on PMs regularly too, in my opinion. There's some white paper publications out there you can get that tell you how to inspect probes, what on ultrasound probe failures was one, and then on the proper care of a TE probe is another one. And then there's a published article that describes what happens when I was talking about two dead elements next to each other or two panels and what it does to the Doppler signal. There's actually an article, a publication that was published in the JDMS. Because it was published, you need to purchase it, but I think you can find some overviews of it, and it actually might be worth purchasing if you're not sure about what that effect is, or if you have some people at your facility that are saying you shouldn't have to do that much testing because it doesn't matter. You may want to get a copy of this article and show it to them so they understand how serious this problem can be. So thank you. Appreciate your attention. We're going to open it up for some questions at this point. My email address in case you want to email me, and the number for AUE in case you want to call in.
Thanks so much, Jen. Fantastic presentation. We do have a couple of really good questions here. The first one, ultrasounds are considered an equipment and cannot deviate from manufacturer's recommended guidelines. Is the speaker saying you can create your own schedule?
So, yeah, this is a very good question. This is a very controversial thing right now. So the CMS said that for imaging equipment you have to follow the manufacturer's recommendations. That presents the issue. As I mentioned earlier, GE actually contradicts what that should be. Which one am I supposed to follow? So yeah, the CMS does that. However, the CMS does not say you can't exceed it. I believe it does. You can only do that, although it actually implies that you read it. I have to admit, it does imply that's all you're supposed to do. I actually think that's just a mistake, and unfortunately, because it's a federal agency, it might take a while to get it fixed. But even one of the lead inspectors doesn't agree with that. But it is what it says. It is true. However, that comes in more effect with Joint Commission. The etiology is still an accrediting organization. In other words, you can get reimbursed. That's one of the reasons that's the main reason that a lot of places do it, actually, is so that they meet the requirement to be audited by some organization that checks your quality. So they still accept ACR. So here's the other problem. CMS is saying one thing and ACR is actually saying something different. So my opinion is that if you're using ACR accreditation for that, you need to follow the ACR requirements, and that may or may not match up with what the CMS is saying. That's an excellent question, and I'm actually, in my spare time, trying to help get that corrected.
Great. Okay, quick one. ACR still requires PMs semi-annually?
No, they do not. They actually, they don't specify the frequency anymore. So that's a good thing, because if, say you actually have an OEM manual that agrees where the user and service manual says one per year, that's what you're supposed to do, right? So, so yeah, you can set your own PM schedule. It can't be less than the annual survey, really. Well, it could be, because if you could say you do PMs are the annual survey, so then you have an annual PM. So no, it's not required every 6 months anymore, and they also don't require you to use 2 transducers at a minimum, as they did before.
Okay, ACR given a time executed and put in place. This particular,
if you submit today,
I'm sorry.
If you submit today,
he continued to say that he received an email a while back that these standards are on hold.
Huh. Well, that's interesting. I didn't hear about that. In December, changing these, and really kind of a mess, frankly, until April when they got the requirements document changed. So I think that's what they're referring to. In December, they actually put some of these things about these changes that I've been talking about, but none of the rest matched that. So it was actually very confusing for a few months there. It was like, wait a minute, you're saying I'm supposed to do this over here, but in this document, it's different. So as of April of this year, you know, I mentioned a couple of things that are still a little bit out of sync, but as of April this year, it has to meet these requirements. The things that I said are requirements, if you submit today, you have to meet those.
Okay, next question. Because of all changes and the big variety of tests, acceptable to perform a QA/QC test on an ultrasound without test equipment besides?
Well, that's a good question, because the way that it's written as a test object must be used. So I guess you might consider yourself a test object. I feel like a tool sometimes, but yeah, I guess. I mean, of course, that is sort of all we had, and most of us do that every once in a while, just a quick check. The problem with that is the human body change, right? So it's not a real good test device as far as that goes. But that's really a good question. I almost have to pose that to the ACR and see what they say. You know, this is on John's carotid. Here's what it looked like. Here's John's liver or something. Just on John's liver. So I'm really sure. I'm pretty sure what they mean is some sort of test, but the word they actually used was off. So I guess I'm not really sure what the answer is to that one. I would strongly urge you to at least try to get some test device that does a little more than this, just because it is very difficult to see on the human body. Though I suppose you knew what your spectrum, your Doppler spectrum looked like in the carotid pulse wave Doppler, which I have to know kind of what mine looks like. So you start seeing some defects there. Certainly it is something that can be used, whether the ACR have that or not, I'm not actually sure.
Okay, Jim, I'll agree with John's liver is quite sensitive. Meds need active Z to run performance testing.
No, you can do it with a phantom, as I explained, so or with a nickel. But I would say, certainly, well, phantoms are not cheap, right? Even the general QA phantoms, which is just the one phantom that will do most, even those are fairly expensive. So if you didn't have anything at this point and you were trying to make a decision, I would certainly, about getting it effective and repeatable and actually allow me to cache two dead elements or two bad elements or two dead channels next to each other.
Okay, next question. What was the procedure again to test certified systems monitor and PACS monitors?
Well, there really isn't one procedure. That's one of the things we've done for years, in which the ACR actually suggested. They have that document I mentioned that's a little document on how to do these tests. I strongly urge you to go grab a copy of that. It's a free download, and it will tell you some of the ways to do that. So what it will do is that count grayscale steps. So look at the gray bar, count as you can actually see, and then if that's then if everybody thinks the system is working correctly, in other words, right? And then when you go back in a few months later to do the testing, if they think something's wrong, you do the same thing. How many scale steps can I see? And if that has, that something's going wrong, it's usually going to be the monitor, especially if it's but yeah, that's one way to do it. Another way is to turn on the test patterns and make sure that you can see, a clear image that's not being distorted in the corners and the kinds of things. There is one test right now specified for that, and they're standard now for image monitors on systems, which I tried to figure out what that says, and it's pretty complicated. It mainly says what you're supposed to test, not how. So anyway, there really isn't a good defined way for that. My suggestion is make sure you've got good color quality, so it's the red, green, blue, especially if you get utility on the system that allows you to do that. And then check to make sure you're getting the full display of the gray sheets.
Okay, thank you. Next question. How about test device calibration schedule, some first call, etc.?
Okay. First call require calibration every year. The nickel actually does not require calibration, but you need to use the Duracell batteries that the user manual says to use. It relies on the B+ voltage batteries, and Duracell batteries don't decay gradually. They hold their voltage until they die. So you're supposed to use Duracells, but there is no calibration required in that either. Phantoms don't require calibration either, and now there are different qualities of phantoms, and I don't want to necessarily get into each one of the manufacturers, but if you're going to use this as a QA device for doing quality testing, you need a test object that does the change. I was saying that the human body may not be the best thing. So there is one brand of phantom, or a couple of brands, that they make phantoms that have a liquid-based medium. Anything liquid-based is going to dry out. Right? So one manufacturer, their phantom dries out daily. The other one, it takes a few years, but it's still changing. So I would urge you to get one that has a lifetime warranty on it because it's not water-based. And then there is no calibration. The pins are fixed in this gel material, and so they don't move around. So no cal required on those. So the only thing would be the first call, because it is an electronic device, and so it does need to be calibrated once a year to make sure it's giving you the right results.
Okay. Does test equipment have to be certified every year?
The test equipment be certified? Well, no, I think maybe that falls into the same answer as for calibration. But no, it doesn't have to be certified. Now, if you change the test device you're using, and you've been doing these tests and you have these baseline of tests, then you need to think about that, and so you would need to do like a transition, right? So if you've been using the Phantom, even though they're not the best, you've been using that Phantom to do those tests, because they do some of those tests okay, right? And now you're going to decide you're going to use, let's say, Active Z to do that. Well, I would suggest you should do, and this is not required by ACR or anything, but I would suggest you want to do a side-by-side kind of thing, right? So do one full set of evidence-based QA tests or PM using both devices and compare the results, and so that you know what the comparison is. And then once you feel comfortable that your new test device is giving you the information that you expect, then just go ahead and start using that one. But there is no requirement for doing that.
Okay, here's another good one. How will we know if probes or transducers are still safe to use? What are the available equipment and or devices we can use?
Oh, good question. So one of the most important things is the electrical leakage tests. As we know, the systems are designed to be double fault tolerant, but if you have a probe that's failing electrical leakage because it has a hole in the membrane or a hole in the bending neck sheath of a TE probe, or it's been run over and it's got a crack in the scan head or something, that's one fault. So then if we have just one other fault, we have the possibility of electrocuting or shocking at least the user or the patient. So electrical leakage testing is really important about the probes and the system. I know the systems don't fail very often. The probes actually will fail fairly often just because of the use that they get and sometimes misuse. But the systems don't fail that often. But I know myself, I would feel extremely bad if I found out I skipped an electrical safety test because I was in a hurry on doing a PM, and then I find out later that somebody got shocked. And one of the main things to worry about again is the power cords, and also frankly the way the wall element might have gotten wired backwards, or maybe the ground on the outlet is messed up or something. So I feel that's really critical, and especially on the probes. As a matter of fact, TE probes, all the user manuals say to do an electrical leakage test, almost all of them anyway, say to do an electrical leakage test of the transducer before you use it again. And GE actually says before and after each use, which is actually the best practice in my opinion. So those should be tested every time because they are very susceptible to getting bitten, or sometimes the bending neck sheath will wear out just from use. And as soon as it's failing electrical leakage, there's a couple things that happen. For one thing, the disinfecting fluid gets sucked into the insertion tube because capillary action is amazing, apparently, how well it can suck Cydex up into a TE probe. I've seen TE probes that are completely full of disinfecting fluid all the way to the connector that plugs into the system. And so that's bad for a couple of reasons. The biggest reason is that then leaks out into the patient during the exam. And if you go on the FDA MAUDE website, the MAUDE database, and you search for this, you will find, and I can send you some examples if you want some, of cases where patients have been poisoned while they were having a transesophageal exam. So it's a patient safety issue. Plus, if you have a probe failing electrical leakage that's right behind their heart, and they forget to remove that when they defib them, and there's one other ground fault on the system, you have the potential to electrocute that patient. So that's a really critical thing, obviously. And then as far as I'm concerned, having some way to tell if all the elements and channels are working properly to the best of your ability with the test equipment you have is really critical because of this Doppler problem where you have dead channels or dead elements that are being used to form the Doppler beam, and what it does to the side lobes of the ultrasound beam is why it screws up. And the result, unfortunately, is it makes it look like you have the classic symptoms of blockage. So, the reason they look at your carotid to see if you're getting blockage of your arteries, right, if they're getting stenosis or blockage. And so when this problem happens, it creates what looks like spectral broadening, which the doctors interpret as turbulent blood flow. It also changes the velocity readings, and it sometimes makes them higher. That's another indication of increased blood flow, is of course an indication of blockage. So when they see that, the next step they usually take, unless they suspect there's something wrong and they get another probe or another system, or they keep trying harder and harder and they finally find part of the probe that doesn't have dead elements or dead channels. So if they don't do that, then the next step, and this has happened, I know people can attest to this, where the next step is to prescribe an angiogram. So you've gone from an exam that's supposed to be safe and non-interventional to something that's not perfectly safe or certainly interventional. So that's one of the most critical things, is to get these unnecessary procedures that actually can cause harm to the patient when it wasn't even needed. And there's been published reports. You can go out and find these studies that were done in Sweden is one of them I'm thinking of, where they found proof that they missed diagnoses and had misdiagnosis of patients that led to patient injuries. So those are the most critical things, in my opinion.
Okay, we got 2 more questions, and then we're going to wrap it up. The next question is, who should be the third party that overviews the QC? Is it in-house biomed or a contracted ISO independent?
In my opinion, as long as they're qualified, it could be either one of those. So if you have, 2 trained imaging engineers that understand this and understand the concepts, and it's especially great if you've got 2 different facilities that have ACR accreditation and you have 2 different clinical engineers that are doing that, then you can have them check each other's work, right? If you don't have that, then it'd probably be best to get either an outside consultant, so somebody who can come in and has the same kind of qualifications so they can take a look at what you're doing and do that. Or you may have to hire a consultant to do that, like maybe hire one of the medical physicists that there's about, I think, 85 or 100 of them in the United States that are considered probably qualified to do that. So those are probably the choices. But the ideal thing would be that you have more than one person trained on this, on how to do this proper testing and how to run the ACR program, and then they can check each other.
Okay, last question, guys. We're going to wrap up. How is this going to change for smartphone attached probes?
Well, that's an interesting question. Well, yeah, that's a very good question. I hadn't really thought about that one. I'm not sure that it will change. There are some rules in some states, by the way, about how many channels a system has to have, so that may come in. The smartphone versions are really intended for emergency room type of things, right? So it's not necessarily meant to be used for diagnosis. So, but as they are able to miniaturize these things more and more, I mean, there was a time when even compact systems really weren't that adequate for a lot of these things, but now there's compact systems that can do all these different tests. They may not do them quite as well or have as fantastic an image quality as a cart-based system, but there's really a lot of imaging power in some of these systems. I mean, there's several compact systems that are 128 channel systems. So at some point, I assume they'll figure out some way. Now, they're going to have some attachment to a smartphone because you got to have transmitters and receivers, right? And I don't think iPhones have that, at least not for ultrasound. But at some point, they usually have some kind of big box that sits in between that has the beamforming electronics that you need. So I would assume that they would treat it the same way, though, at the point where that becomes. Now, smartphones don't meet the imaging display requirements, right? They don't have the pixel resolution that's required for these. Matter of fact, iPads don't until they got to the Retina display. And I know my orthopedic guy was looking at an x-ray one day of my knee, and he's using an iPad, an old iPad, to do it, and I yelled at him. I was like, you can't use that. That doesn't meet the requirement. It doesn't have good enough resolution. So smartphones, I'm pretty sure, aren't quite at that level yet, although I'm not absolutely sure, to tell you the truth, but I don't think the resolution is quite there. But assuming that they do get there and they have some beamforming capability that they attach to it, then I'm guessing that the ACR would say you have to do it the same way.
Okay, great. Well, again, Jim, thank you so much for this fantastic presentation. Thank you to AUE for sponsoring today's webinar. Everyone out there, remember a survey is going to appear on your screen immediately following the conclusion of today's webinar. And please always remember to visit imtechnation.com/webinars to register for the next webinar. Also, if you want to go to mdexposhow.com, we are currently taking call for presenters for the Nashville show March 29th through the 31st. So go to mdexposhow.com and submit your call for presenters. Thank you again, TechNation. We look forward to the next webinar. Have a great rest of the day.